This video is sponsored by Wuxin with their WXR printer. Hello and welcome to another episode of Nathan Builds Robots. I want to take this as an opportunity to go over all of my 3D printers and kind of explain what the difference is in practical terms between CoreXY and Bedslingers at a variety of different size and price points. I'm curious to hear about your opinions in the comments section below and whether you agree with my assessment of Bedslingers versus CoreXY printers. People don't really like to talk about these issues as much, but in the real world, what I'm about to talk about is really the most important thing. 3D printers aren't super reliable machines. It's not like a car that's designed to run 200,000 miles before it breaks down over the course of 20 years. Or like an airplane that's designed to fly millions of miles before it's eventually decommissioned after 30 or 40 years. 3D printers are kind of throwaway devices that break down rapidly, they're always having issues, and you want them to be as easy to service, inspect, and repair as possible. When you look at these CoreXY machines, sure, they look beautiful on the outside, they've got all these nice plastic panels covering up all the ugly bits and circuitry, but when something goes wrong on one of these printers, it's a lot harder to diagnose because you can't see what's going on as easily. If you take a look at one of these Bedslingers, virtually all of the critical components are easy to see, inspect, and repair. If I have a problem with my X-axis, I can easily inspect the belt, the motion control system, the stepper motor, versus on these CoreXY machines, when you start having issues, it's like, oh man, where do I get started? I gotta inspect this whole machine, I gotta look at all these different subsystems, and add to that, they're harder to reach, harder to access, harder to take parts out and replace them. It just ends up being less usable in the real world. With Bedslingers, there's a clear separation of parts and their function. Just for example, if you have issues on your y-axis, it's usually pretty obvious that it's on your y-axis. Or if it's on your x-axis, it's pretty obvious that it's on your x-axis. And if you have a fan that's not working or something, it's really easy to just look at the printer and see what's going on with it. Versus these CoreXY machines, they're kind of marketed as these hit print and forget about them kind of experiences. And sure, that's great when it's working, but when things break down, it's a real headache. Less people have the expertise required to work on these machines, and it's a much steeper learning curve in order to diagnose and repair these things. And this isn't just an issue for random breakdowns and malfunctions that you might need to fix. It's also an issue for the long-term usability of these products. There's parts that are just glued into place. They're like, oh, should we figure out some way to have these attached with bolts or screws or something? No, let's just glue them into place. And then when they break, people just have to throw the printer away. That's the case on these K1s, on the new line of Cheetah machines, and on the Bamboo Lab printers. They're gluing all these rods and bearings in place so that if they eventually break down and fail, you're going to have to throw away either a large subcomponent of the machine or the entire frame just because one small component broke. If you look at most Bedslingers, you can completely disassemble these things into a million pieces and put it back together without much training, and you'll be able to find broken parts and repair them and keep these things running indefinitely. That's why I like to say, if you're going into a zombie apocalypse type situation, or if you only have one printer to bring with you to a desert planet or a uninhabited island, I think a Bedslinger is going to be the better option for you, because if something breaks, you'll be more likely to be able to fix it. And that's a real issue about serviceability with these things. I could have two of these Creality K1s or two of those Bamboo Lab P1Ps and have them both break in different ways. And on a Bedslinger, you'd be able to take this subcomponent off of one and then the subcomponents off another one and recombine it into something that works in the end. But on CoreXY machines, due to all the parts being really nested together and often being highly proprietary, you're not going to be able to mix and match parts nearly as easily. Once one of these machines breaks down, you're really going to need that manufacturer support, which is an area that's been sorely lacking in the 3D printing industry. That's why I really like the Ender 3 series, because it's built around standardized parts and it's really easy to find replacements and just mix and match things and get it working. There are some CoreXY machines that are very modular and easy to repair. Take for example all of the open source CoreXY projects, like the designs from the Voron team or Annex Engineering and RatRig. They're all pretty modular, but there's still a lot more work to fix and repair than a Bedslinger. If your printer is too small, like this little Ender 2 Pro, then you're going to be really limited on the things that you can print. But if you step up to a super large machine like this K1 Max or this CRM4, you're going to be able to print basically anything and not be restricted in terms of size. When it comes to Bedslingers, you have availability of a lot of large and small options. Most CoreXY machines are between 220 and 300 millimeters in terms of the build area. They tend not to stray too far outside of the standard build envelope, because the added complexity and cost makes it so that smaller machines are less economical, and the extra long belt pathing and full enclosure add a significant cost to large machines. Just as an example, I have the CR-M4 over here that's about $1,000. This has a 450 by 450 build area versus the largest off-the-shelf CoreXY machines. You have the CoreXY K1, which is 300 by 300. It still doesn't touch the size of this large Bedslinger. Now there's exceptions to every rule. There's the Voron V0, which is like a really small CoreXY machine, and the Rook by Rolahan. That's a fellow YouTuber that's come up with a nice low-cost CoreXY design for a really small printer. And that has a build volume that's similar to this Ender 2 Pro. So there are small options for CoreXY printers, and likewise there's really big options out there too. If you look at the Voron Trident, you can get builds of that up to 350 by 350. The Ratrig V-Core has options that go up to, I think, a ½ meter by ½ meter. And at Midwest RepRap Festival, I interviewed Luke from Luke's Lab, who is building large CoreXY printers up to 1 meter cubed. So of course there's going to be exceptions to every rule we throw out there, but in general, you've got a lot more size options for commercially available Bedslingers than CoreXY machines. One of the nice things about CoreXY machines is their frame inherently lends itself towards having an enclosed printer. And that enclosure is going to offer you a big advantage when it comes to printing materials that like to shrink a lot. So ABS, nylon, polycarbonate, all of these high temperature materials that are prone to shrinking and warpage are going to be really nice to print on these closed framed CoreXY machines. If you're printing on a Bedslinger, these tend to not be enclosed. You can put a big box. Whoa, hello? Woo, woo. Oh my. Anyways, so you can put a big box enclosure over your Bedslinger printer. However, that's going to take up a ton of space because you have to make room for the bed that moves back and forth, and it's just really not as optimized for being fit inside of a box as these CoreXY machines are. Having each printer have its own personalized little enclosure is really nice because that's going to unlock the ability to print those higher temperature materials, and it should result in stronger prints because there's going to be less internal stresses from uneven shrinking and curling forces that are happening as that 3D printed plastic is cooling down and kind of changing shape and size. So in general, you're going to get better prints out of an enclosed printer. The flip side of that is with Bedslingers, they're open to the environment, so it's really easy to get cooling air blasted over your parts. You're not going to have to invest in a bunch of extra fan ducts and venting systems to get your parts to cool off, because it's just kind of sitting there in open air. Plus, the motion of the bed moving back and forth is kind of wafting the air around the part that you're printing and provides additional part cooling. So it's inherently easier to cool parts down on a Bedslinger. So in practical terms, what does that mean? Well, basically, if you're printing with an unenclosed printer, like most Bedslingers, then you're going to be limited to using PLA, PETG, TPU, and a bunch of fiber-reinforced plastics. Now, fiber-reinforced plastics is kind of a surprising one for a lot of people. You would think that you would need a high-performance, high-temperature build volume printer for printing carbon fiber-reinforced nylon or carbon fiber-reinforced polycarbonate. But the reality of it is, when you add that carbon fiber reinforcement, that actually reduces the amount of shrinking that occurs, because those fibers are kind of locking the plastic in place and not letting it shrink as much. So you'll actually be able to still print high-performance materials that are fiber reinforced on an unenclosed Bedslinger. Materials that off-gas, like ABS, they produce some kind of acrylic fumes that you're going to want to vent out. On an open printer like a Bedslinger, even if you're printing ABS parts where the warping isn't going to cause too much issues, you're still going to be off-gassing, and it'll be a lot harder to capture and remove all of those fumes. Printing that in an enclosed printer makes fume management much simpler because you already have the enclosure containing all the gases. At that point, all you need to do is attach some kind of vent tube to the back of the printer and suck those fumes out and either vent them outside or into a filtration system. Your CoreXY machines are just going to be a lot more capable in general when it comes to printing more different types of materials. But since 90% of the time I'm printing PLA and PETG, Bedslingers work fine. If you compare two similar printers, like this Soval SV07 Plus and this CoreXY K1 Max, they have identical print volumes, but the MSRP of these two machines is wildly different. This one is like $800 to $900, This SV07 Plus, I haven't got confirmation on the pricing yet. Let's just average it out and say $400. It's half the price of this K1 Max. And it comes with clipper, it comes with the ability to print at high speeds, it's got an all-metal hot end, it's got really advanced part cooling. So it's a really nice printer, and it's coming in at a very low cost. This is Creality's latest offering, the Ender 3 V3 SE. It has a standard 220 by 220 build area. This Creality K1 is Creality's flagship printer that's the exact same size. It's got a 220 by 220 build area. The retail price of this Creality K1 is $600, compared to the retail price on this Ender 3 V3 SE is $200. That means you could get one of these machines or three of these. And in terms of total overall output, I think you'd be much better served by an army of Bedslingers compared to just a few CoreXY machines. Alright, and the other thing that everybody seems to be going crazy about these days is print speed. Everybody wants that 13-second speed benchy that just gets blasted out in a few seconds. For most of us, 3D printing is a hobby. We're not in production, we're not in engineering or rapid prototyping. We're just printing things out occasionally for the fun of it and just as gifts or just random useful things around the house. Now, if you are in a production environment or doing some type of engineering, then having a printer that's as fast as possible has some real benefits. But if your printer is just sitting idle 90% of the time, like most of these printers, then having a super fast printer isn't going to make a huge difference. Let's say you get a printer that prints twice as fast. Well, instead of your printer sitting idle 90% of the time, it's going to be sitting idle 95% of the time. Unless you have a real need for that speed printing, then it's really not advisable to go out and buy a more expensive, faster 3D printer. That said, there are some undeniable benefits of having a CoreXY printer. With the print head being the only moving part of the system, that allows your motion control system to be as light as possible, and that thing can just be flying around really easily. You can push really high accelerations and print head speeds. With bedslingers, especially on large bedslingers like this CRM4, the actual mass of the bed becomes the largest moving piece of the system, and accelerating that back and forth is pretty difficult because of how heavy it is. Add to that, if you're making a multi-kilogram print, then that added mass of the object you're printing is going to affect the kinematics of your 3D printer. All of a sudden your y-axis is going to be 2 to 3 times heavier, and if you're already pushing the limits of your machine in terms of acceleration and print speeds, then that's going to cause some major issues for you, like layer shifts or failed prints. But in general, for most standard printing, a bedslinger is perfectly sufficient for the job. And the reason for that is your x-axis is super light, and the additional weight of that y-axis can be compensated by putting a larger stepper motor on the y-axis than on the x-axis. So you can tune the printer so that it's going to work fine despite the axes being of unequal weights. When it comes to absolute print speed, sure, CoreXY machines have an easier time, but bedslingers are no slouch either. Take for example these two new offerings from Creality and Elegoo. We've got the Elegoo Neptune 4, which is one of my favorite bedslingers, and the new to the market Creality Ender 3 V3 SE. Both of those are incredibly fast printers. They both have top speeds of 500 millimeters per second. The Ender 3 V3 has a firmware limit of 4,000 millimeters per second squared in terms of its maximum acceleration. The Elegoo Neptune 4 has a maximum acceleration of roughly 5,000 millimeters per second squared. The top-of-the-line machines from Bamboo Lab and Creality, those have maximum printing accelerations of roughly 10,000 millimeters per second squared, which is twice as much acceleration, so that will increase your print speeds. However, when it comes to printing critical features, they drop down to like 2,000 and 3,000 millimeters per second squared anyways. So you're going to be slowing down for those critical features, and it ends up not making as big of a difference as you would think. Plus, I'm able to print some incredibly massive parts on this CRM4 because I installed a large diameter nozzle. So that means you're extruding a ton of plastic, but the actual print head isn't moving very fast. Now, I still consider this to be a very fast printer, despite it only moving like 5 millimeters a second, because it's laying down so much plastic and it's allowing me to build really large parts. If you look at high-speed bedslingers like highly modified Ender 3s, or this Ratrig V Minion, or the Wuxin WXR, these are still bedslingers, but they're designed to run really fast. So I don't think you should be constraining your thinking to being like, oh, if I have a fast printer, it has to be a CoreXY machine. Bedslingers can be fast too. It's just people don't typically push them that fast because they're typically designed to be that lower cost entry into the market, the one that's simpler to use and is just used for basic printing. Alright, now I want to take a break to talk about today's sponsor, Wuxin. Wuxin is a 3D printer manufacturer based in Fort Collins, Colorado. The Wuxin WXR is a flagship 3D printer that has been thoughtfully designed as a turnkey solution for both beginners and experienced professionals. Its main features include high-speed printing with speeds up to 500 millimeters per second, no data collection before, during, or after printing, easy plug-and-play setup in 10 minutes, industry-leading customer support, perfect first layers out of the box, open source and customizable, American designed and built, and silent operation. So if you want to help support my channel and support a 3D printer manufacturer based in the United States, make sure to check out the link in the description below to check out Wuxin's 3D printer offerings and their filaments. Thanks Wuxin for supporting this episode. For these CoreXY machines that are built out of a lot of proprietary parts, your upgrade paths are severely limited. It's basically, you get upgrades if the manufacturer gives you upgrades. Versus on Bedslingers, due to their open and modular construction, it's really easy to just take some random part that you want to put on your printer and just stick it on there. Like on one of these machines, I put a Micro Swiss NG extruder on there. It was really easy to do because you just take the old tool head off and put the new one on and wire it up and it works. On these CoreXY machines, they're all built around these proprietary tool heads. If you just imagine the hot end and extruder technology that we're going to have in 2 to 5 years, you'll be able to retrofit all of your Bedslingers to take advantage of that new technology. But a lot of these CoreXY machines will kind of be frozen in time. You won't be able to upgrade them nearly as easily, so they're just going to be kind of falling behind in terms of their capabilities. And this Moddability makes Bedslingers a lot more fun to own and use, in my opinion. I have a ton of fun just upgrading my printers. Since I've got these CoreXY printers, it's like I can't really do anything with them, so I kind of get bored with them and stop using them. Versus on my Bedslingers, I'm always able to just pull parts off and put new stuff on there and just upgrade and tinker with them. And that's part of what brings me a lot of pleasure in terms of the 3D printing hobby, is kind of building a personal connection with your printer, customizing it, and really making you feel like it's your own. It's also a lot easier to do crazy experimental stuff on these printers because they're so upgradable and moddable. You can really tailor them to a specific purpose. Take for example my CRM4. I put a really large orifice nozzle on there so it can print like really fat beads of filament, and that means I can turn my layer heights up to like 3 millimeters per layer and turn my extrusion widths up to like 1 centimeter, just laying out these fat beads of filament. And that's really fun for artistic effects, and you get really interesting engineering properties, and it lets you play around with a lot of different things that you wouldn't be able to do on a standard CoreXY machine. I've been doing some experiments adding mesh reinforcements to my printed parts. This would be much more difficult to do on a CoreXY machine. On a CoreXY machine, your parts are inside of this enclosure, so it's really hard to just like set things into the printing area while it's running. Versus on a Bedslinger, when you pause the print, it'll just present the part out to you like on a platter, and you can do weird stuff with it. You can embed bearings or reinforcement meshes like this, and it's just much easier to do crazy scientific experiments on these. If you look at some of the other highly experimental mods going on in the 3D printing space, like 5-axis 3D printing, people are almost always using Bedslingers to build their 5-axis 3D printers because you've got such a more open and moddable architecture. If you ever have to take apart the belt system on your CoreXY printer, you're going to be like, man, this is complicated. When you look at these Bedslingers, the belt system is basically a pulley, a stepper motor, and then it's attached to the thing you want to move. Versus on this, you've got this complex system of like 20 plus bearings, and then your belts that have to be wrapped around in this complex way. It's just a lot more challenging to understand and troubleshoot. Also on Bedslingers, you have a shorter overall belt length, and the belts are smaller and stiffer. On these CoreXY machines, one of the big issues that you have with larger CoreXY printers is since the belt length is so long, when the stepper motor turns to pull on the print head through that belt network, it has like a very long belt path to go through. It can be anywhere between 0.5 meter to 2 meters of belt length that it's having to pull the print head through. That whole length of belt can stretch and cause more ringing issues. Typically they say not to go above 350 millimeters when you're dealing with a CoreXY machine. There are exceptions to that rule, and if you step up to a larger size belt, then that issue can be easily compensated for. Now, I mentioned that it's a downside that these Bedslingers have a large, heavy bed that has to move back and forth. However, since it's located down close to the table, it's actually not as bad as you might think it is because, your center of mass is so low and the moving mass is so close to the table that it's not going to cause it to rock around that much. On a typical CoreXY machine, the moving parts are up towards the top. So the printer's going to rock around a little bit more just because of the moving mass being higher up. Most of the advantages of a CoreXY machine come from its enclosure and overall frame design. Since this is built with a solid enclosure and frame all the way around, that makes the printer very stiff and very able to resist rocking and deformation as that print head is moving back and forth. So you can push higher accelerations. Compare that to a Bedslinger. You've got the heavy mass of the bed and the relatively flexible Z-axis. Since the Z-axis on a typical Bedslinger is just kind of, I call it like a tombstone. It's just stuck into the ground and it can wobble back and forth like this. It's like a tombstone or a springboard. Basically, as you've got vibrations being induced by this Y-axis moving backwards and forwards, that's going to cause that springboard or tombstone of the Z-axis to wobble back and forth, and that's going to cause major ringing and all sorts of problems with your print. However, there's a very simple solution to that problem, and that's in the form of these struts that just complete a truss triangle that kind of holds that tombstone up in place, and that just stiffens everything up and negates 90% of the issues that you get with ringing on a Bedslinger. Benefits of having a CoreXY printer: the print head is lighter, allowing them to push higher accelerations. The overall packaging is usually smaller because you just need room for the print area, plus a little bit of margin on the outside to make room for all the mechanical components. Versus on a Bedslinger, you usually need about 2 times your print area in terms of the amount of space it takes up on your desk, because that bed is sliding back and forth and it requires clearance in front of and behind the printer. So there definitely are some packaging and acceleration advantages of having a CoreXY machine. The other thing about these Bedslingers is they're going to be easier, cheaper, and faster to assemble. Most of these CoreXY machines come pre-assembled, and it's like, well, that's faster than having to put together a Bedslinger. Someone's having to put this thing together, and they're charging you for that. That's why these come with a higher MSRP, because the assembly process is more involved, more complicated, requires more materials, so it's just kind of a more expensive printer to produce. When you look at Bedslingers, they're cheaper and easier to produce, which has a huge number of advantages. First of all, your MSRP goes down, which is great because everybody likes having money in your pocket. Also, you've got much less expensive shipping costs. With these Bedslingers, you usually take the top gantry off and fold it flat, and then that all ships in a relatively compact package. Versus on these CoreXY machines, since they come pre-assembled, you need a box that's bigger than the printer itself in its assembled configuration, so you end up with these massive cardboard boxes that have to be pretty expensive to ship. So shipping something like this K1 Max is probably $80 to $200, versus shipping something like this SV07 is probably going to be $20 to $60. So you're saving a ton of money on these Bedslingers in their assembly and shipping costs. Plus, a lot of these CoreXY printers are built in China, which, they have very low manufacturing costs there. It's a lot cheaper to hire employees for manufacturing in China than it is in other places. So when you get these CoreXY machines, due to how labor intensive they are to build and put together, you're pretty much having to buy from a foreign source. Versus with Bedslingers, since they're easier and cheaper to manufacture, it's not quite such a penalty to be manufacturing them in the United States or Europe. Also, I feel like a lot of comparisons between CoreXY printers and Bedslingers are inherently unfair because you're comparing a more expensive, higher-end machine to a lower spec, cheaper machine. Typically, when you're looking at a Bedslinger, you're looking at something that was designed and built with a few goals in mind, including low price, easy assembly, cheap shipping costs. They're basically aiming for a lower segment of the market, so they typically don't put the highest end components on there. When you look at printers with huge quality control defects, they're usually Bedslingers because that cost-cutting mentality kind of lends itself well to building a Bedslinger. You don't want to spend all this time and development making a CoreXY machine if you're trying to make a super cheap printer. If you want to make a super cheap printer, it's almost always going to be a Bedslinger because that's just the cheaper way to make a printer. Now, that's not to say that Bedslingers are lower quality than CoreXY machines. There's been bad CoreXY machines released, there's been bad Bedslingers released, and there's been great CoreXY machines released and great Bedslingers released. It really comes down to a company-by-company basis and a product-by-product basis. For example, this Elegoo Neptune 4 is one of the best printers on the market. It has really good print quality, it can print really fast, and wouldn't you know, it's a Bedslinger. And they're able to produce this high-speed, high-quality printer because they're saving the money by going with the Bedslinger architecture, but they're putting the money towards things that actually help you out, like better part cooling, a better hot end, running clipper, and all that kind of stuff. Just because it's a Bedslinger doesn't mean it's a cheap printer, although there certainly are some examples of Bedslingers that have extremely low build quality and have issues right out of the gate. I consider Bedslingers to be much more beginner-friendly because you can physically see everything that's happening and you really learn how the 3D printer works just by watching it move around. You can see the x-axis and the y-axis and all the motion components. It's going to be much easier to understand, troubleshoot, and repair a Bedslinger compared to a CoreXY machine. If you're a complete novice and you hit the ground running with one of these Bedslingers and you're just printing things insanely fast, like sure, that's going to be a great experience for you. It'll be very entertaining and fun. But when something breaks, it's so complicated that like your noob brain is going to be broken by the complex stuff that's going on up there. Versus on a Bedslinger, you're much more likely to be able to like, oh, I see what's going on. Let me figure out how to fix that. Let me post a couple pictures to Reddit and then someone will be able to guide me through repairing this thing. Also, if you're a beginner, you're probably going to be printing PLA for the first like 10 spools of filament anyways. So a Bedslinger is going to be perfectly good for that. But I think when you look at things overall, Bedslingers are the optimal choice for a hobbyist because you're printing with PLA most of the time. When you're printing materials like PETG or you just want higher quality prints, you usually end up turning your print speeds down anyways. So it's like, do you really need that high speed and acceleration? On my customized large nozzle diameter printers, I'm usually flow rate limited in terms of my print speeds. Even if I had the fastest moving print head in the world, I'm still limited on how fast I can feed filament into the print head and melt it, so I'm ending up having to move at a certain speed regardless of how fast the printer actually is. So what's the big takeaway here? Should you get a CoreXY machine, or should you stick with the venerable old Bedslinger? Well, in my opinion, for most people, I think the Bedslinger is a better option. It's going to be easier for beginners to use, and if you're running a print farm operation, it's going to be cheaper to acquire, maintain, and upgrade these printers over time compared to equivalent CoreXY printers. That's not to say there isn't a place for CoreXY printers. Their advantages in terms of print speed and acceleration and the ability to print more advanced materials is really nice. However, if you don't need that capability, there's no point in paying for it. Now, there are a lot of printers that fall in kind of the middle ground, like this Wuxen printer, which is like a fast Bedslinger, or the Prusa XL, which is like a slow, unenclosed CoreXY machine, or the Bamboo Lab P1P, which is like a half-baked CoreXY machine that doesn't have an enclosure, so really it's going to be a fast printer, but it has a lot of downsides of the Bedslingers. It's definitely a spectrum of different options on the market. However, I think in terms of bang for your buck, Bedslingers are really hard to beat. And they're just a lot more fun for me to use because I get to upgrade them and do all sorts of weird experiments with them. CoreXY machines are great if you have a specific need for that, like say you need a print to be finished as fast as possible, or you need to be printing out of ABS or polycarbonate, then definitely go for that. But for 90% of people, I would just go with the good old Bedslinger. But the message I want to leave you with is, whether you're team CoreXY or you're team Bedslinger, one thing we can all agree on is that resin printers suck! I'm curious to hear about your opinions in the comments section below, and whether you agree with my assessment of Bedslingers versus CoreXY printers. Thanks for watching, and I'll see you in the next video.